Hi, I'm Matthias, and I'd like to talk with you about learning the most important tech skill. So which skill is the most important? Well, let's start with a little story. So picture this. Here we are walking through the desert. Oh look, an unexplored cave! Haha, turns out this cave is just the size of a closet and only contains this magic lamp. And how do we know it's a magic lamp? Well, that's what this massive manual says. But we don't have the time to read that whole thing, so hey, thankfully there's a quick start guide right over here. Step 1, rub lamp. Step 2, make 3 wishes. Step 3, question mark, or sell his lakefront property. Step 4, profit. Sounds good. Let's do this. So we'll read the full manual later, right? Right? All right, anyway, rub the lamp. Ooh, nice, a genie. So for my first wish, I'd like to learn React. I was recently trying to debug a website and I kept tripping over the React stuff I didn't know my way around. Genie says, done. I don't need to know the explanation, but you'll be able to understand React by Monday. By Monday, I say? Aren't magic wishes supposed to be instant? Ahem. Page 42 in the manual clearly states that brain-altering wishes require several days to start working and may need some weeks for full effect. If brain fog persists for more than 4 hours, please seek medical attention. Okay. Then for my second wish, I'd like to learn Clojure. It was the top-paying programming language in the Stack Overflow Developer Survey 2022. Genie says again, you don't need to say why, but okay, done. And since you clearly didn't read the manual, I'll just tell you that you'll understand Clojure by next Thursday and be an expert in it in a couple of months. Well, I'm on a roll now, but this is my last wish, so I need to make it good. Based on my first 2 impetuous wishes, the pattern is obviously that I need to keep learning new things to stay relevant in tech, right? So, Genie, my third wish is to be able to learn any technology I want both effectively and efficiently. Ideally even faster than those first 2 wishes, but I'll take what I can get. Now you listen here, you little silly mortal. No judge in any courtroom of magical things would side with you on this one. You are clearly wishing for infinite wishes of the sort you just got, so your request is denied. Nah. Yeah. Okay, so here's the deal. Learning new stuff really is important, critical for making a career in tech. But we don't need magic, and I will still show you how you can make that third wish come true. So that means that what I'm about to tell you is literally more powerful than magic, huh? Well, at least the type of magic I made up for this talk specifically so I could make that claim, but just ignore that. Okay, so here's my plan for the rest of our time together. I'll briefly explain the context and why the general skill of learning is so important for a tech career. Then I'll walk through some key fundamentals of brain and learning science. After that, it's time for some techniques you can use to help you learn more quickly and effectively. And finally, we'll look at my 3 tips for how you can sustainably apply all of this in your everyday life. Sound good? Then let's dive in. Okay, context. An ancient Greek philosopher said, the only constant is change. And wow, does this ever apply to technology, eh? It changes ridiculously much and bewilderingly fast. If you've never seen the Hacker Noon article, How It Feels to Learn JavaScript in 2016, it's a little old, but it's still good, you might want to open it up in a new tab for later. It's a hilariously told story of a current practitioner trying to help someone who fell behind catch up. But the point is that tech keeps advancing whether we like it or not. And although we do not need to jump on every new thing, if we want to stay relevant, we cannot live in the past. And staying relevant is not optional if we want to stay employed, right? I've said it many times and I'll say it again now. In a tech career, your ability to learn is your primary skill. We recently published an article on the Pluralsight blog about exactly this, titled, I Work in Tech. Should I always be upskilling? And if you don't immediately feel the need to yell, yes, of course, to that question, then you might want to read it. Anyway, this is why I call my talk, Learning the Most Important Tech Skill. And also why I call it Learning, the Most Important Tech Skill. Anyway. Next up, the fundamentals of learning science and how the brain works. People often ask, since there's so much information to learn, how do I remember it all? And my answer to that is that you don't. Let me explain with an exercise. Remember these four things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 6, 2, 8, 3, 1, 8, 5, 3, 0. Next is 0, 7, 7, 0, 6, 5, 0, 8, 4. And finally, 9, 9, 9, 9, 9, 9, 9, 9, 9. Got them? Now, I need to tell you that 299,792,458 meters per second is the speed of light in a vacuum, and 340 meters per second is the speed of sound at sea level, and 11 meters per second is the flight speed of an unladen swallow. European, of course. But you don't need to remember those speeds. They were just there to push out the 4 number sequences out of your short-term memory. So, now then, do you remember the 4 things? Chances are good that you still remember that the first one was 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And you probably also remember that the last one was 9, 9, 9, 9, 9, 9, 9, 9, 9. With me so far? But you might well have forgotten that the second one was 6, 2, 8, 3, 1, 8, 5, 3, 0, and the third was 0, 7, 7, 0, 5, 6, 0, 8, 4. If you did, don't feel bad. But why is this? Well, it's because your brain parsed, understood, and changed the first and last numbers into the patterns you recognized about them. Your brain did not remember the numbers directly. It remembered what it understood. So for the first sequence, that was, these are the digits from 1 to 9. For the last set, it remembered, that's 9 nines. But I would be very surprised if you could make immediate sense of the other 2 sequences. And actually, the third one was wrong when I said it the second time. The original sequence was 077065084, not 56. Did you notice the switched digits? Very few people do, and even those who do usually start doubting themselves. But I am pretty sure you would have noticed if I had tried to pull the same trick and said that the first set was 1, 2, 3, 4, 6, 5, 7, 8, 9, right? Because you know how to count to 9, and you're appropriately confident in that ability. In case you're curious, the second sequence I gave is the first 9 digits of tau, which is twice pi, and the other one was the decimal ASCII numbers for MAT, the first 3 letters of my name. These are not quite as simple as 1 to 9 or 9 nines, but now that you know what the patterns are, you might be able to tell them back to me even next week. Sure, you might need to translate what you do remember, meaning what you do understand, into the actual number sequence by looking up tau or pi or using an ASCII converter or something, but your brain now has something that it can grab onto. And that is key. Because in the real world, we don't need to memorize numbers or other information. Instead, we need to understand various technologies well enough to look up and double-check details when they might matter. No one gets paid to sit in meetings and recite quotes from documentation pages, and those docs don't solve business problems by themselves at our desks either. But our biggest takeaway is this: you remember what you understand. So focus on understanding over everything else. That is what learning is all about. And of course, my reason for going through this exercise was to help you understand this point, not just hear me say it. But that means that you'll probably remember it too. Anyway, let's look at how this applies to your learning. It's easy enough to say that you should understand things, but I want to help your brain do that by teaching you about mental models. A mental model is a simplified representation of reality that your mind uses to anticipate events or draw conclusions. Basically, it's what your brain builds when you understand something by organizing new information into hierarchies. It includes recognizing patterns and is a kind of data compression for the brain, really. That's what let you remember the 2 easy sequences from the exercise we did earlier. When you use logic instead of memorization, that is also based on a mental model. For example, you don't remember that 1, 2, 3, 4, 5, 6 is a larger number than 9, 8, 7. You understand that it is because it has more digits. Here's a quote from Professor David Skillicorn of the School of Computing at Queen's University. Anyone can learn faster by structuring the information. This is another one of those common trade-offs. Getting right into it can feel satisfying, but taking some time to organize can increase effectiveness, even if it doesn't feel so satisfying in the short term. What's more, mental models don't just make learning faster, they actually make learning easier too. Like we've seen, our human brains are much better at remembering related concepts than unrelated details. And when we try to squeeze in too many details, we can often find that the other ones get pushed out. Just like when I listed those different speeds after the number sequences, right? But with a mental model, the more you build and refine it, the easier it becomes to learn more information. And what you learn is far more valuable to you too, because it becomes a part of your decision-making process. So even though learning faster is great, learning more effectively is arguably even better. The interesting problems in life are trade-offs, and you'll often be faced with situations where you won't know all the details involved. To be able to work effectively in a tech career, you'll need to be able to predict likely behaviors, identify your assumptions, and then validate your theories through investigation and testing. A strong mental model is the critical foundation you need for these steps. And it also happens to be the process of learning applied to your situation, and not just some technology. So, whether you're building them on purpose or subconsciously, mental models are the critical must-have for a technology career. You can't succeed without them. Okay then, now that we understand the basics of mental models, let's look at how we can go about intentionally building them. The key is to continually ask, how does this information fit into or change my mental model? There are two parts to that. Some information will simply fit into the mental model we already have. The new information is similar to what we've seen before, so it strengthens our existing mental model. This type of information often feels calm, comforting, and confidence-inspiring. But some other information won't fit because it somehow conflicts with the mental model we've built up to that point. This conflicting information may feel chaotic or confusing, but it is actually the most critical type of information for learning. This is because we need to do what learning scientists call double loop learning. In this type of learning, instead of just using information to make new decisions, you use it to refine your mental model. Let's take a simple example. If I say that 3 numbers in a sequence are 1, 2, 3, what do you think the next number is? If I said 4, wouldn't that feel satisfyingly like what you expected? Because your mental model is probably that I'm just counting. But what if I said that after 1, 2, 3 comes 5? Why 5? Why did I skip 4? This is in conflict with the mental model of counting, so you're forced to consider other explanations. Now what if I told you that after 5 comes 8 and then 13? Do you see it now? This is the Fibonacci sequence that adds the previous 2 to get the next. And I skipped the very start of the sequence just to make a point. Insufficient information can lead you astray. Not always, mind you, but often enough that we should always be looking out for it. But still, it's best to start with a simple explanation and only complicate your mental model when the information leads you to, whether directly or indirectly. But that also means that to learn more efficiently, we should actively seek out the sorts of things that cause us to rethink our mental model. Even though it might not feel good to be confused, it's kind of like building muscle strength. If we don't feel any soreness, we're probably not making much real progress. When we work through the confusion to reshape our mental model into something that is better at organizing all the information we've seen, then we convert more of the not yet seen information into that calm and comforting kind too. This is like our mental model just leveled up, ding! And it can handle future situations more easily with its improved strength. Anyway, an important takeaway from all this is that learning progress is not measured by how much learning material or information you've consumed, but rather by how well your mental model supports information. So be careful not to get lost in your learning and just go through the motions. In particular, don't keep powering through what you're trying to learn if you don't really understand any of it or aren't paying attention. If you're not constantly incorporating information into your mental model, then you're not learning effectively, and you're arguably not making any real progress. At best, you're just trying to memorize stuff, and it's kind of a waste of time. Because of this, slowing down and backing up can actually be excellent tools to help you learn. They can refocus your attention on your mental model and how it handles the new information. Also, pay attention to how well your learning is going so that you can tweak your approach and learn in new ways. Basically, use double loop learning on your double loop learning. It's learnception, right? In any case, refining your mental model into a mature one is the slowest and most important part of your journey toward expertise. And this also answers the questions that people so frequently ask of, am I ready to something? Sit my exam, apply for that job, take on this project, whatever. If you seek out potentially conflicting information and you can still incorporate it pretty smoothly into your mental model without destabilizing it, then my answer would be yes, you're ready. Okay, now let's run through a few learning science-based techniques that you can apply. It seems only fitting that I should start with the primacy effect. Actually, the primacy effect and the recency effect are both a part of the serial position effect, which is, according to Wikipedia, the tendency of a person to recall the first and last items in a series best, and the middle items the worst. This effect is another reason I put the harder two number sequences in the middle in my exercise, to make it less likely that you would simply remember them. But you can leverage this for learning by reversing it. Now, I know I've been harping on how you need to focus on understanding and not memorizing, but building a mental model still requires you to keep the information in your head, yes, remember it, for long enough to incorporate it into your mental model. And if you want to turn this idea up to 11, then always try to give your brain a mental model puzzle to solve, like all the time, in the background. I mean, try to keep your brain's hopper, in a sense, full with something that conflicts with your current mental model. Even if you don't successfully work through that conflict and update your mental model every time you do that, that's fine. To be honest, your success rate can be objectively terrible at that, and this will still be a super strong technique just because you can give it so many opportunities to pay off. Anyway, doing this, incorporating the quick learning puzzles into your daily thought process, it can be a huge advantage for you in your tech career. So, to get even more concretely practical here, this is all about intentionally using the little minutes. Little minutes happen all over the place. While standing in line at the grocery store, during your commute, taking a shower, on your break, hoping the kids will get in the car soon, falling asleep, in the waiting room at the dentist, or whatever. Whenever your brain isn't otherwise occupied. These things happen crazy often. Just try making a note of every time this happens in a day, and you'll very quickly get annoyed by how much time you're wasting by making those notes. So instead of making a note like that, maybe read one instead. Like I just implied a minute ago, you can keep a list of questions that you have while learning, and then bring that up whenever you have a little minute somewhere. Read the top couple and then get back to your waiting or have your shower or whatever. That said, you won't always have enough questions in your list. Maybe it's because the learning time that you had set aside got interrupted by some emergency, or maybe you fell asleep, or maybe something else. I'm not judging. The reality of life is that we don't always manage to do what we hope or plan to do. That's okay. But lots of the little minutes that you do get offer more opportunity than simply thinking about something. For example, if you're commuting by bus, you may well be able to watch one more video in an on-demand course that you're taking, or maybe 2 or 3. And if you get interrupted or distracted, no worries, you'll just get back to it later, right? Or maybe you're standing in line at the store and it's harder to watch a video. Well, maybe you can read an article you came across or some documentation page that you opened up. I always have an insane number of tabs open in every web browser on every device I have, so I'll pretty much never run out of things to read. But if you prefer like the peacefulness of no open tabs, tab 0 or something like that, you can still do something like bookmarking or putting a link in your notes, right? Little minutes are powerful, and they are probably the #1 untapped opportunity for most people here to improve your learning. Next, we have distributed practice. Again, quoting Wikipedia, this is also known as spaced repetition, the spacing effect, or spaced practice. And it is a learning strategy where practice is broken up into a number of short sessions over a longer period of time. Just to be clear, distributed practice is the exact opposite of cramming. They've done studies to compare the effectiveness of various learning techniques to each other, and distributed practice was one of the very strongest ones. And actually, distributed practice is one of the reasons why many people learn more effectively from on-demand video courses than they do from in-person classroom training. I don't have time in this talk to cover all the reasons, but having things broken down into lessons that are usually under 10 minutes long makes a huge difference in how people can process information, as compared to classes that are 1 or several hours long. The point is that it's much more effective learning to go through 1 lesson each day than it is to go through 7 lessons each Saturday. Way more effective. And worst of all is the whole, oh, I just went to a week-long destination training course that jams together what should be literally hundreds of separate lessons. So, to learn effectively and efficiently, do whatever you can to break apart your learning into small chunks and then spread them out on your calendar like paint splatter all over, little dots everywhere. All right. The other super strong technique for learning that's called out by that comparison study I mentioned was practice testing. Practice testing is about putting yourself on the spot to answer some question relating to the material you are learning. There are a lot of ways to go about this, but I'll warn you against using question dumps that you might find online. Many people have lost job opportunities because they've used those things. Sometimes they've lost those things for ethical reasons, and sometimes because they actually misled those people from proper learning. So just don't put yourself in such a disadvantage. But there are reputable sources of ethical practice questions, especially when you can be sure that a training author has created their own questions for their students. And even more interestingly from the study, the article about that study highlighted that their finding was practice testing is effective when you create the questions yourself. It doesn't have to be someone else creating those questions for you. Okay, another very strong technique, though it wasn't compared by that particular study, is the one of teaching others. Yes, I mean that you will learn by teaching. The point is that going through the process of explaining what you think you've learned to someone else, even if that someone else is a mirror or a rubber duck, that will quickly show you where you still are a bit shaky. Then you can go and shore up that particular thing and repeat. This way, you'll suss out all of those little bits of confusion in your mental model that were hiding in some corner of brain fog. Historically, the medical field has sometimes used this teaching others technique as a part of their see one, do one, teach one. And in terms of additional resources, I'll link to a good video that I found that explains the Feynman technique. Actually, I've added that video to my curated YouTube playlist of a lot of really good learning to learn videos, and I'll link to that later. Also, you can check out the Wikipedia page for rubber duck debugging. Yes, that page actually exists. All right, now there are many more techniques to consider than I have time for today, but I do want to give you a quick heads up that the idea that each person has a primary learning style, such as visual, auditory, or kinesthetic, well, that's all bunk. Sorry, it's not supported by learning science. Now that said, it's because which of those modalities is best is actually going to depend on the material and not the person more often. For example, would you say that the best way for someone to learn the shape of a map is to describe it to them audibly because that person calls themselves an auditory learner? No, they'd still get much more benefit if they see that map visually. And on the flip side, virtually everyone should get hands-on with as much of what we're learning as possible, because that both locks it in and offers us new ways to refine our mental models. Okay, to wrap things up today, I want to give you my 3 quick tips for how you can work learning into your daily routine so that you can have a successful and sustainable tech career. The first thing is to set achievable and valuable goals. If you just need to learn to swim, there's no point in making it your goal to beat Michael Phelps in Olympic gold medals. That rather lofty goal is not valuable to your circumstance. Instead, target a valuable scope of learning like an industry certification. Technical certifications have gotten a ton better than they used to be, and I find them to be exceptionally valuable as well-defined learning targets and stepping stones to even bigger goals. The second thing is to make consistent progress. In particular, make it a daily discipline to intentionally learn for at least 5 minutes. The biggest obstacle to learning tends to be simply the starting. So just start. Keep starting. Set a timer so that you don't end sooner than 5 minutes, but do try to let yourself go over that 5-minute mark whenever possible. And try to every day make a note of, say, 3 things that you noticed during your learning. Maybe those things fit smoothly into your mental model, or maybe they don't and you can let them percolate in your brain and glance at them later. Either way is a win. 5 minutes per day is a very small commitment, so you should be able to incorporate this into your life. But, that said, when you have a crazy day and you miss it, don't sweat it either. Don't even keep track of how far behind you are or anything like that. Just move on and try to do what you can each day. It's not worth the mental capacity or stress to even think about making up for it, and carrying such a learning debt would actually work exactly opposite the whole point of this being a thing that you can achieve each day. The third and final thing I want to tell you about is to make inconsistent progress as well. I already talked about using the little minutes, and that is exactly what I mean. But I also mean that you can turn most things in life into a learning opportunity by simply engaging your curiosity. Explore the why of everything. Doing this almost always leads to something interesting. Plus, it helps you to continuously refine your mental model and also helps you to flesh out the breadth part of your T-shaped skill set. Okay, well, there is a ton more to say about all of this, but it's gonna have to wait for another day. The only thing I have time left for is a ridiculously rapid recap. You ready? All right. A successful tech career requires continuous learning. In fact, your ability to learn is your primary skill. You remember what you understand, and that understanding that your brain builds is called a mental model. Your mental model is your basis for making decisions and being effective with tech. So, learning tech is all about building and refining your mental model, not remembering things. It is easy to learn new information that fits with the mental model you already have, but information that conflicts with your mental model and confuses you is how you improve and make it more effective. So, to learn more efficiently, seek out information that conflicts with your mental model. Your brain can continue learning in the background while you do other things. So, to learn efficiently, keep reminding your brain about things that confuse it. Take advantage of all the little minutes that you have in your day and split your learning up into small pieces to take advantage of both distributed practice and the serial position effect. Suss out the holes in your mental model by asking yourself questions and trying to teach others. And finally, to incorporate learning into your life, engage your curiosity and make daily consistent progress toward achievable and well-defined learning targets. Whew! Finally, I'm going to leave you with a list of resources that you can use to continue developing your skill of learning. I mean, don't spend all of your time just learning about learning, but if you invest a bit more time into it now, it will pay dividends for the rest of your life. Because learning is the most important tech skill. Thank you.